Hello everyone, my name is Salman Rahman and I'm an application engineer focusing mainly on ST's MEMS products. This is a continuation of our video series where we explore together the TMOS infrared sensor. And in this video, we will see how we can utilize the new MEMS Studio software to evaluate the TMOS infrared sensor. For this evaluation, we are going to use the MKI 1090 ProfiMEMS board. And along with that, we are going to use the MKI 231KA TMOS infrared evaluation kit. So let's get started.
So to get started with this tutorial, we first need to download the MEMS Studio software from st.com. Search up MEMS Studio on the search bar. Once you land on the MEMS Studio page, you can click on the Get Software button. And as you can see, MEMS Studio is available on Linux, Mac, and also Windows. And since I'm using a Windows operating system, I will go ahead and click on the Get Latest button here. Now that you have downloaded and installed the MEMS Studio software, let's go ahead and launch the software. You can see 4 options on the left hand side bar, starting with the Connect, Advanced Features, Data Analysis, Algo Builder, Firmware Programming. On the right hand side, you can see the supported boards that MEMS Studio currently supports for different evaluation boards. The first thing we will do is we will flash the latest firmware on the ProfiMEMS board. To do that, let's go to Firmware Programming. Currently, the board is not connected. So the way to enter the ProfiMEMS board into the debug mode, or known as DFU mode, what we can do is we have to press on the Ref2, the debug button, while keeping the USB cable outside or not connected. As you keep holding the Ref2 button, you need to insert the USB-C cable to a USB port on the PC. Now, let's go ahead and select the interface, which is DFU. And as you can see, the device has already been detected by the software. Now let's go ahead and check the firmware directory. Since we're using the STEval MKI 109D ProfiMEMS board, let's go inside that folder and let's select this binary file. Now let us go ahead and program the ProfiMEMS board with the latest binary. And this may take a few seconds to a minute. As you can see, the firmware downloading process has been completed. Now let's go ahead and power cycle the ProfiMEMS board. To do that, you can either press on the Ref1 power cycle button, or you can also unplug and replug the USB cable. Once you have done that, let's go back to the Connect tab. As you can see, the communication type is serial and the communication port is identified as COM10. So let's go ahead and connect. Once you reach the page here, you can either type on the device part number, which is STMicroelectronics STHS34PF80, and once you see the device name, you can go ahead and select the device. We have landed on the sensor evaluation tab. There are multiple information that we can get from sub-tabs. So the first one is the quick setup, which has two buttons. The first one is the easy configuration, which allows a user to configure the device with default manufacturer settings for the sensor. You can also choose your desired configuration from the drop-down options. Once you desire to go back to the default settings, you can also use this reset device configuration button to go back to the initial point or configuration. Now let us go to the next tab, which is the register maps. The registers map are divided into three segments: the basic registers, the embedded registers access, the embedded functions registers. In all those registers, you can both read and write any value that is permissible. To know more, you can also check the datasheet and the application note. On the Save to File tab, we can save all the log files that we will be taking from this evaluation. To do that, click on the Browse, go to a desired directory or folder you want to save your log in, type a name, and click on Save. You can also select or unselect the data headers that are useful or not useful for your evaluation. Now, let us start the sensor data logging. On the data table, you can see the data table tab displays all the data in a tabular form. The saved logs that we just enabled from the previous step will also have similar data structure. On this tab, you can also select or unselect your desired data headers. Now, on the next one, the Data Monitor tab. This tab displays all the data for each data header, sample by sample. At each specific sample, the data from all the headers are displayed. Now, let us check the Line Charts tab, which enables the visualization of all the sensors' raw and algorithms data. As you can see on the top plot, the red signal displays the T object data, and on the bottom hand side you can see the T ambient data. Now, on to the next Algorithms tab, we can see all the data from all the three embedded algorithms. So the first one is for the T ambient shock. The second one is for the T motion data. And the third one displays the T presence data. On the Smart Digital Algorithm tab, we can observe the activities and configure the smart digital algorithms that are embedded on the TMOS sensor more closely. On the first tab for presence, you can observe the T-object signal on top in red color and the corresponding T-presence signal and the presence flag. Similarly, you can also check out the signals and flags for T-motion and the ambient shock embedded algorithms. It also allows you to select the desired configuration settings for the embedded algorithms. For example, you can configure the threshold, the hysteresis, and the low-pass filter settings that is suitable for your application. You can also reset all the embedded algorithms using the Reset Algorithms button. The Communication and Power Settings tab displays useful information about the serial interface that is being used. It also allows the user to measure the current in real time for the configuration that is currently set. As TMOS is a very low power passive device, the current consumption is in microampere, making it a great solution for occupancy detection applications which require very low power consumption. MEMS Studio also allows to load or save any configuration for future or reference. For this last portion of the tutorial, I would like to introduce the IR algorithms tuning feature on the MEMS Studio, which allows a user to simulate the embedded algorithms output from the TMOS sensor for different configurations on an already logged data. In order to get there, click on the Advanced Features and go to the IR Algorithms Tuning tab. Firstly, let's go ahead and select the log file you'd like to simulate the embedded algorithms output for by clicking on the Browse button. Once you have done that, select the specific configurations for presence, motion, ambient shock algorithm. You can choose the desired threshold, hysteresis values, and also the low-pass filter settings. Click on the Run Processing button and you can see the corresponding output for each embedded algorithms. And this way you can fine-tune to the optimal configuration that is required for your application. Now let's wrap up the video with a real application example. In this demo, we will see how the TMOS can be utilized to detect presence or absence of an user sitting in front of a laptop. As you can see here, the TMOS is strategically mounted on the bezel of the laptop and is connected through a ribbon cable to the DIL24 board, which is mounted on the ProfiMEMS board and which is obviously connected to the PC. For this demo, the sensor has been configured to all default settings except for the threshold value of the T presence was set at 550 LSP. Now, as you can see on the top hand side is the T object data in red color. In the middle is the presence or T presence data, followed by the presence flag on the bottom. As you can observe, since there is no one present in front of the laptop, the presence flag is set to low. As the user walks in and sits down in the chair, you can see there is a spike in both T presence and T object. Correspondingly, the presence flag is now set to high. As the user sits and engages with the laptop, the T presence flag remains high. Now, as the user walks out of the field of view, you'll observe that T presence goes down. Correspondingly, the presence flag is now set to low. Thank you for watching this tutorial. To learn more about this sensor, please visit st.com.